Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So in this question, we are talking about a car and how it accelerates compared to a house. So for the car, it's able to accelerate, right? Because it has an internal source of energy, that is the fuel, right? That it burns, that allows it to turn its wheels and to exert a force on the ground. Now, to get a close up of the wheels, right? As the wheels turn, let's say if it wants to move forwards, it would turn in this direction, right? Forwards is here, then it would turn in this direction, and because the wheels don't slip against the ground, it exerts a static friction force, right? It experiences a static friction force from the ground that is opposing the direction in which the wheel is moving with respect to the ground. So with respect to the ground, the wheel is moving backwards, and so the static friction force is actually forwards, right? And this is actually a reaction force by Newton's third law of the ground on the car, right? Because the car exerts this force from the wheel on the ground. And this is what actually causes the car to accelerate forwards. On the other hand, for a house, the house does not have any source of internal energy that will allow it to move, and it doesn't have any wheels as well to allow the house to slide on the ground, right? With that static friction and that allows it to move. So right now we are given actually that a car, and want to find what is the maximum acceleration of the car. Since we know that the car accelerates via this static friction force on the wheels, you can use that to find what is the maximum acceleration. So the maximum acceleration occurs when the static friction is a maximum, right? And that is because if you go beyond the static friction, then what will happen is that the wheels will start to slip, and when it slips, the frictional force that is acting would be lower because the coefficient of kinetic frictional force is usually lower than the static friction. So when you will get a smaller friction force, and thus the car would accelerate slower, right? So we gotta find what is our maximum static friction. And we know that static friction maximum would be given as mu s times the normal force that is acting on the drive wheels. Now we are given that the drive wheels hold 2/3 of our total mass of the car. And so the normal force in this case would be equals to 2/3 of the entire weight, right? So that is 2/3 times the weight of our car, that is 1,500 kilograms times 9.81 meter per second square, which gives us 9,800 newtons. So this is the maximum static friction. And from this maximum static friction, we can get our acceleration, right? This equals to ma. Our acceleration would be equals to 9,800 divided by the entire mass of the car. It is 1,500, and we get 6.53 meters per second square. So it is the maximum acceleration.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
In this question, we have a system of two blocks A and B, both are same mass of 1 kg. They are connected by two ropes, which is R1 and R2, in which both of them are not massless. Right? The ropes have mass of 0.25 kilograms or 250 grams. We are given that the system is accelerated upwards by a force with an acceleration of 3 meters per second square. We want to find what is the force F. Right? So very simple. We draw the free body diagram of the system. So let us consider the system as the entire square over here. There is force F that's acting on it, and then there is gravity. Right? The net force would cause an acceleration of 3 meters per second square. So that is the total mass times 3 meters per second square. And the net force is given as F minus Fg. Right? And the total mass over here will be the mass of the two blocks, which is 2 kilograms, plus the mass of the ropes, which is 0.5 kilograms. So that is 2.5 times 3. Right? Taking the force of gravity to the right hand side, right? Fg is equals to total mass again multiplied by 9.81, right? Due to gravity. So we should get our F to be equivalent to 32 newtons, right? After bringing the force of gravity over. Now we want to find what is the tension at the top half of our rope. So to do that, we're going to consider the free body diagram of our block A. So block A experiences a force coming from the top, which is F, which is equals to 32 newtons. It experiences gravity, right, Fg, from itself, and it experiences the tension coming from the rope R1, from the top half of R1. So now we can find what is the tension by knowing what is our force of gravity over here, and knowing that the net force acting on A, F net, must be equals to the mass of A multiplied by the common acceleration, which is 3 meters per second square. So this is equals to 32 minus force of gravity minus the tension from the top half of rope 1. Rearranging this equation, we should get the tension from the top of R1 to be equals to 19.2 newtons. Right? We just have to substitute the values in. This is 3, this is 1 kilograms, this is 1, this is 9.81. Right? This is the top half. Now to consider the bottom half. Now if you consider the bottom end of the rope, this is a different story, right? So now we have to consider the acceleration of our block B with the rope R2. So this entire system has to accelerate upwards at 3 meters per second square as well. And this force that is providing this acceleration will be equal to the tension of rope 1 at the bottom, right? So let me just put this as TR1 prime. So the net force, let me draw the system over here, which is B plus the bottom half of R2, right? R2. The overall free body diagram of this system would be, first we have gravity, then we have the tension coming from the bottom end of R1, and we are given the net force must be equals to the mass of B plus mass of rope 2 multiplied by the common acceleration, and the net force is also equals to T of R1 prime minus Fg. And in our case, Fg, force due to gravity would be mass of mp plus mass of R1 times g. So rearranging this equation, we should get the tension at the bottom end of R1 to be equals to mb plus R2 A plus G. So we should get 16 newtons. Right. And now we can repeat this to find out what is the tension at the top end of rope 2. So considering just B itself, we know it experiences gravity. It experiences the tension from rope 2, TR2. It also experiences TR1 prime, right? The tension from the bottom end of rope 1. What we have to do, we just need to take the net force again. The net force acting on B would be just mb times the net acceleration. We equate that to TR1 prime minus TR2 minus Fg of B. Right? And the force due to gravity on B would just be mb times g. Rearranging this equation, we can get TR2 to be equals to TR1 minus mb A plus g. Right, and we should get 3.2 tension at the end of rope 2 to be 3.2 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
We have a 1 kilogram block in the figure in your textbook is tied to the wall with a rope. It sits on top of the 2 kilogram block. The lower block is pulled to the right with a tension of 20 newtons. The coefficient of kinetic friction at both the lower and upper surfaces of the block is 0.4. What is the tension and what is the acceleration? So the tension of the 1 kilogram block and the acceleration of the 2 kilogram block. So we have M1, M2, F, and UK. 1 kilogram, 2 kilograms, 20 newtons, 0.4. So let's find the tension first. So block 1 does not move. And so the sum of the forces in the x direction is equal to 0. So the sum of the forces in the x direction, you have the force of kinetic friction minus T1. So move the T1 to the other side. And this is mu k m1g equals T1. Plugging all of those values in, and you get 3.92 newtons for the tension. So Fk is pulling to the left, T is pulling to the right, or the opposite way. Okay, so to find the acceleration, we look at that free body diagram that we have, and we have, again, the forces in the x direction is equal to 0. So this is F minus F1 minus F2 minus Fa equals 0. We're looking for Fa, so it's F minus F1 minus F2. So you have 20 newtons minus mu k mg minus mu k m1 plus m2 g. Plugging in our given values, and we find that Fa, also recall that this is mass 2 times the acceleration. So finding the acceleration, you divide both sides by m2, and we get A is 2.15 meters per second squared.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have the coefficient of kinetic friction between the 2 kilogram block, and the table is 0.3. What is the acceleration of the 2 kilogram block? Okay, so let's look at this. So you have T1, T2, T3, you have M1G, M2G, M3G, you have the normal force, and you have friction that's going to pull this backwards. And then it is accelerating to the right. Okay, so looking at T1. T1 is equal to M1G plus M1A. So it's kind of the acceleration of the system, not just the acceleration of the second object. So this object is going to go up, that object is going to go down. Okay, we also have T2 minus T1 is equal to M2A plus mu2 mu M2G. So we looked up the forces of what's happening between these two objects. We also have M3G minus T2 is M3A. So we can rewrite this as T2 is M3G minus M3A, and we can combine this all into one equation. So going from here, M1G. So minus M1G minus M1A plus M3G minus M3A minus plus U M2G. So we can combine these and solve for the acceleration. So all of these have G and an A in common, so you can split them up. You have M1 plus M2 plus M3 times A equals M3G minus M1G minus mu M2G. So solving for A and plugging in all of our values, we get 2.29 meters per second squared.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have a figure in your textbook where you have a pulley and it is connected to two blocks. This one is 2 kilograms and this top one is 1 kilogram. It's being pulled to the right by a force of 20 newtons. It gives you the coefficient of kinetic friction as 0.3 between the lower block and the surface. And between the lower block and the upper block, it's also 0.3. What is the acceleration of the 2 kilogram block? So let's do a force diagram. So you have the force due to gravity for both of the blocks. You have the normal force of both blocks. There is tension and you have the force due to friction. So on the top block, it is going to pull it to the right, and on the bottom block, it's going to pull to the left. Okay, so we can do a sum of forces. So the sum of all the forces in the y direction, it's in equilibrium, it's not moving up or down, so it's 0. So if we're looking at the first block, you have n1 minus or equals m1g. So from equilibrium, if we're looking at all the forces, n1 is equal to m1g, n2 minus n minus 1 minus m2g. You also have the normal force as m2g plus m1g. Okay, so For the x components, you have mass 1 times the acceleration is t minus mu and 1. M2a is the force minus the tension minus mu and 1 minus mu and 2. So we can substitute these two together. M1 plus M2a is equal to, we're adding F minus 2 mu N1 minus mu N2. The T's would cancel. So we don't actually care what tension is. They didn't give us the tension, but it cancels, so all is okay. So solving in for these values, we get A is equal to F minus 3 mu N1G minus mu N2G over M1 plus M2. And so the acceleration in this step, you are plugging in for N1 and N2 in this equation. Okay, so the acceleration is 1.76 meters per second squared.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have a rope attached to a 20 kilogram wood sled, and it pulls the sled up a 20-degree snow-covered hill. A 10 kilogram wood block rides on top of the sled. If the tension in the rope steadily increases, at what value of the tension does the box slip? Okay, so let's do a free body diagram to start this off. So, okay. So here is your 20 degrees and the ground. So we want to do one for the box and one for the sled. So, okay, so for the box, you have the box here. This is 20 degrees. You have the force due to gravity pulling down, the force due to friction pulling up, and then the normal force. So this is N1. We are letting up the incline be X and out be Y. Okay, so that was for the box. And then for the sled, you also have 20 degrees. You have F2G. You have 2 rounds of friction. So F1 and F2. You have the normal force in 2, and you have the tension. Okay, so we start by looking at the sum of all the forces in the y direction, since it is not moving in the y direction. So the sum of all of the forces should be 0. You get N1 is equal to M1G cosine of theta. So you also have the mass times the acceleration. M1A is equal to F1 minus M1G sine of theta. So that's in the x direction. So we know that friction is mu times n. So solving for A, you're going to get mu s g cosine of theta, since f is equal to us and 1, minus g sine of theta. So the m1s will cancel. So that was for the box. Now let's look at the sled. So for the sled, you have n2 is equal to m1g cosine of theta plus n2g cosine of theta. So Newton's second law gives you m2a equals t minus m2g sine of theta minus f1 minus f2. So you can plug in for friction and substitute N1 and N2. So remember, F1 is us N1, F2 is us N2. And solving for T, you get T is equal to M2, mu sg cosine of theta minus g sine of theta plus m2g sine of theta plus mu s m1g cosine of theta plus the kinetic friction, which is m1g cosine of theta plus m2g cosine of theta. So substituting in for all of those values, you need the coefficient due to friction to keep it from sliding. So you will get that the tension is 154.71 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have capital M, which is 100 kilograms. If it takes it 6 seconds to reach the floor after being released from rest, what is the mass on the left? Okay, so let's first look at our forces. So here you have tension, here you also have tension. Here's lowercase mg for the weight, capital Mg also for the weight, and it is accelerating downwards. So we know mg is equal to ma plus t. So if you look at the tension, it's mg plus little ma. So that means capital Mg, capital Ma plus lowercase mg, case ma. So solving this, moving ma over, and combining terms. So we have that m is equal to g minus a over g plus a times capital M. But we don't know the acceleration, so we have to figure that out. So we know that h is equal to a t squared over 2. That means a is equal to 2h over t squared. They gave us the height as 1 meter, and they gave us t is 6 seconds. So this gives us an acceleration of 1 over 18 meters per second squared. So plugging these values into little m, we get 98.87 kilograms.
हम लोग पे sir? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have a 10.2 kilogram block as shown in the figure held in place by a massless rope passing over two massless frictionless pulleys. Find the tensions T1 to T5 and the magnitude of the force. Okay, so you have the sum of all of the forces that are in equilibrium. So T1 minus mg equals 0. So T1 is equal to mg. We know what m is, we know what g is. So this is approximately 100 newtons. We also know that T2 equals T3 equals T5 because they are the same rope. So let's look at the lower pulley. So if you're looking at the lower pulley, T2 plus T3 minus T1 equals 0. So T1 is equal to T2 plus T3, but those are equal. So this is 2 times T2. So T2 equals T3 equals T5. We know what T1 is. T1 divided by 2 is 50 newtons. So here we have 50 newtons. Now looking at the upper pulley, you have T4 minus T2 minus T3 minus T5 is equal to 0. So T4 is equal to, all of these three are equal to each other. So T2 plus T3 plus T5 is 3 times T2, which is equal to 150 newtons. So we also need to find the force. So to find the force, we have T, let's get that in frame. T5 minus F is equal to 0. So F is equal to T5. So F is also equal to 150 newtons. Oh, sorry, 50 newtons. Excuse me. T5 is equal to 50 newtons. So F is also equal to 50 newtons.
हम लोग पे sir? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have the coefficient of kinetic friction between the 2 kilogram block, and the table is 0.3. What is the acceleration of the 2 kilogram block? Okay, so let's look at this. So you have T1, T2, T3, you have M1G, M2G, M3G, you have the normal force, and you have friction that's going to pull this backwards, and then it is accelerating to the right. Okay, so looking at T1, T1 is equal to M1G plus M1A. So it's kind of the acceleration of the system, not just the acceleration of the second object. So this object is going to go up, that object is going to go down. Okay, we also have T2 minus T1 is equal to M2A plus mu 2 mu M2G. So we looked at the forces of what's happening between these two objects. We also have M3G minus T2 is M3A. So we can rewrite this as T2 is M3G minus M3A, and we can combine this all into one equation. So going from here, M1G. So minus M1G minus M1A plus M3G minus M3A minus plus U M2G. So we can combine these and solve for the acceleration. So all of these have a G and an A in common, so you can split them up. You have M1 plus M2 plus M3 times A equals M3G minus M1G minus mu M2G. So solving for A and plugging in all of our values, we get 2.29 meters per second squared.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have this figure and it shows a mass m resting on a 20-degree slope. It has coefficients of friction of mu s 0.8 and mu k is 0.5 with the surface. It is connected via a massless string over a massless frictionless pulley to a hanging mass of 2 kilograms. Okay, so we have this information. Looking at the figure, we will also have friction. I will pull it to the left. Okay, so let's start with block A. The sum of all the forces in the y direction are 0 because it is in equilibrium. So for part A, we want the minimum mass that will stick and not slip. So if it's not slipping, it's not moving. So you have MAG equals the tension. So the tension is equal to 19.6 newtons. So let's isolate block B now. So the sum of all the forces in the y direction are equal to 0. So you have the normal force as well. So the normal force is equal to mg cosine of 20 degrees. And in the y direction, in the x direction, you have the tension is equal to negative mg sine of theta minus mu s n. Remember, it's sticking and not slipping, so it's mu s, not mu k. So we have m. So this is mb. So we have mb, we have g, we know sine, we know mu, and we have an equation for n. So this gives us the tension is also 19.6 from the other side. So you have 19.6, and we want to solve for MB. So solving for MB, these would be positive. So MB 9.8 sine of 20 degrees plus 0.8 times n. This would give us a mass of 1.8 kilograms. And then part B, if this minimum mass is nudged ever so slightly, it will start being pulled up the incline. What acceleration will it have? Okay, so if we want to find the acceleration, we'll look at the forces. So the sum of all the forces is equal to the mass times the acceleration. So the mass of B times the acceleration. The sum of all the forces are T minus mg sine of theta minus, now it's moving, so it's mu k n. So the masses are the two, this is equal to the mass total times the acceleration. So both of those masses added together. So you get the acceleration is 1.3 meters per second squared.